When you reflect KLMJ over the y-axis and then translate it down 9 units, in what quadrant will K prime, L prime, M prime, J prime lie? Oh, there's a typo. Forgot to fix that. I caught it last period, but I forgot to fix it. And then afterward, write what the rule is. You know how some warm-ups are meant to be like deeper thinking ones, and then I'm trying to help you with it and we work through it? This is not one of those warm-ups. This is a very basic warm-up. I'm not trying to stump you. One of the reasons I put this warm-up on here was because on the test, there's quite a few questions that ask about the quadrants, and I wanted to remind you what the quadrants were named because that wasn't built into the lesson. So that's one of the motivations behind this warm-up. Let's start by naming the quadrants from algebra. Woohoo! So you always start with the quadrant where everything's positive, and then you make the letter C for like the coordinate plane, right? Yeah. So we go 1, we're going 2, 3, and Roman numeral 4 is a 1 and a V. So those are the names of the quadrants. When we reflect this over the y-axis, I'm not going to be perfect here. I'm not even going to try. It's going to end up somewhere right here. And then when we translate it down 9 units, it will definitely fall somewhere in quadrant 4. So that is where, now let's write the rule. It's really important that you can write a rule given any set of transformations that you are asked to do. So let's write the rule. If I begin with x comma y, how would I say that transformation in coordinates? So first we reflect over the y-axis. Reflect over the y, that means change the x. So if you reflect over the y, you change the x. If you reflect over the x, you change the y. So we're going to change the sign of the x. And then we're going down 9, which means that affects the y. And we know that going down means to subtract. So that would sum everything up that we did in one handy-dandy rule right there. Negative x comma y minus 9. Okay? Homework answers. The homework was translations and reflections. This is what your quiz is going to be over. You have your first quiz tomorrow, and this is all it's over. This one page of homework. Translations and reflections. Super basic, easy quiz. We just want to start getting some daily grades in the grade book. So that's what we're doing tomorrow. Not the challenge quiz. That'll be next week. Super easy quiz. Translations and reflections. Let me know which problems you need me to work or if you see any errors in our homework answers. Starting with number 12 from the homework. Oh, and 20? Okay. Reflect the following figures according to the given information, then list the coordinates of the pre-image and the coordinates of the transformed image. Okay, so getting the coordinates of the pre-image is not really a geometry task. It comes from middle school or from algebra. 1, 2, 3, 4, 5, 1. So negative 5, 1. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1. Did I count right? Did I get the coordinates right? Hopefully. Now, I'm just going to use my rule. I'm just going to use my rule. I'm not even going to really use the coordinate plane. Remember, I'm not going to use the fact that I'm finding the distance away from the line of reflection and I'm going the opposite. No, we don't do that when our line goes diagonal. That's easy to do when it's horizontal or vertical. I am simply going to use my rule. And the rule says switcheroo. Switch places. So I'm just going to switch. 1, negative 5, 5, negative 2, 1, 7. I'm going to plot that in a new color. All right, so 1, 1, 2, 3, 4, 5. That is A prime. 5, 1, 2, 3, 4, 5, 1, 2. B prime. And C is 1, 1, 2, 3, 4, 5, 6, 7. C prime. Connect the dots. Doesn't that look cool? So that is that obtuse triangle. I think it's obtuse. Yep. Reflected over the line y equals x. And yes, it's going to overlap. All right. Next one. Reflect this over the line y equals 2. Okay. So y equals 2 means it's going to hit my y-axis and it's going to hit it at 2. So I go to my y-axis and I go to 2. And this would be a good opportunity for me to show you the other way to reflect something on the coordinate plane. There's no rule on your list that says, here's how to reflect over the line y equals 2. There's no rule. So instead, you're just going to count. So how far away is B from the line of reflection? 1, 2, 3. So I'm going to go 1, 2, 3 above. I'm going to call it B prime. A is 1, 2, 3, 4, 5, 6, 7. So I'm going to go 7. 1, 2, 3, 4, 5, 6, 7. C, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This has got to be so fun just watching Miss Stanton count. Okay, and D, 1, 2, 3, 4. Oh, it's the same as A. Right next to C. Okay. Best I can do. All right. So that is the figure reflected over. And all right, so A is -4, 9, and that was the one y'all were asking about. The rest were correct on the homework answers, okay? Pavin's asking if we need to memorize the rules. So, yes, you do need to memorize the rules. Number 14, this is a good problem. This one is not as laborious as the last one. You're not going to sit here and watch me count forever. All right, reflect point L over segment KP. Everyone go to their paper and draw segment KP if you haven't already. You need to picture point L. If I crease my paper and the crease coincides with segment KP, where is L going to land? Think of creasing that figure on KP. If I crease it on KP, L is going to land right there at J. So you're thinking, which other point is equidistant from KP as L is? So L is, kind of this far away from KP. Which other point is that far away? See what I'm saying? So you do need to draw the segment in, okay? 18 says, write the resulting coordinates of the image given the coordinates of the pre-image and the description. All right, so the pre-image is -2, 6. I want to reflect over y equals x, and I want to translate up 10. All right, we'll write the middle step in so we don't get confused. Reflect over y equals x. Well, that just means trade places, switcheroo. Boom. I just reflected over y equals x. Now I'm going to translate it up 10. We know that means y plus 10. So that's how we end up with 6, 8. 19. 0, 9, translated up 2 and left 3. So up 2 changes the 9 into an 11, and left 3 changes the 0 into a -3. Then I want to reflect it over the x-axis. Remember, reflect over the x, change the y. So I'm going to change the y. -3, -11. Okay, so yesterday we did translations and reflections. So if you have your little vocab sheet out, you're going to fill in the blank. You're going to fill right here, this blank. A rotation or a turn is a transformation in which every point moves along a circular path around a fixed point. So you're just writing the word circular. So if you've ever turned a doorknob, you've performed a rotation. If you've ever gone on a Ferris wheel, you've been a part of a rotation. What else? When I'm driving a car, I'm rotating the steering wheel. Lots of rotations all around us. We are generally, yes, we are rotating right now, the Earth, right? Very good. We generally do rotations in increments of 90 degrees, and we're going to do them counterclockwise. I need you to know what counterclockwise means versus clockwise. So here's a clock. The hand of the clock travels this way. That's how the hand of a clock travels. When you watch a clock, I know we don't use analog much anymore because we all have everything digital, but it is still relevant. You still need to know. So counterclockwise means we're going to go opposite the way that a clock does. Opposite the way that a clock does. Opposite the way that a clock does. So these are our go-to basic rotations. They're going to be counterclockwise, and they're going to be in increments of 90. 90, 180, more, 270. What would it be if we rotated 360? We'd be right back where we started, right? Okay, so let's see if we can come up with some more rules. Are you ready for more rules? Do we need more rules? More rules so that we can rotate things in increments of 90 counterclockwise without having to graph it every time, okay? So if we had the time, what I would do is I would give you a point. and I would give you some patty paper. Do you see how this kind of looks like patty paper, that see-through paper? I would give you those two things, and I would tell you to plot the point and plot the origin, a T at the origin right here. And then I would tell you to rotate your paper 90 and find out where the point lies, and rotate it 180 and find out where the point lies. So instead of you doing that individually, we're just going to do it and watch all together. So we're going to rotate that cute little puppy in increments of 90. Let's see where A begins. A is at 2, 4. So there's our original point, 2, 4. Where is it going to land if I rotate it 90 degrees counterclockwise? Dun, 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 dun. 90 degrees, we need to line up our origin again. Where did A prime land? What's the coordinate? -4, 2. -4, 2. All right, let's do it again. Let's rotate this with our patty paper. Rotate it 90 degrees and line it up again. What are the coordinates of A double prime? 180 degrees. Does this look familiar, Kendra? -2, -4. Because you were asking about the -x, -y. Okay, and one more time. 90 degrees again for a total of 270. And where do we land? 4, -2. Let's see if we can write a rule for these. None of these were coincidences. This is what happens every time you rotate a figure or a point in increments of 90. So let's see if we can figure out what's going on here. If I call this one XY, what would I call a 90-degree rotation? Let's see. -4. So we took the Y value and we made it negative. We took the Y value and we made it negative. What did we do? We took the X value and we didn't touch it. So there's your rule for 90 degrees. Don't worry, I'll sum it up on a different slide, okay? All right, what happened here? Look at the original. I took X and I made it negative. That 2 became -2. I took Y, 4, and I made it negative, -4. So there's your rule for 180. Woo, there's a lot of rules. And now let's do 270. All right, it looks like I took Y and I didn't do anything to it. And it looks like I took X and I made it negative. Wow. All right. We just derived, I don't know if I could use that word, but we just came up with our rules for rotations. Don't write down the 0 degree on your notes. Make sure you only write down these. 0 and 360 are not important to write down. So you're on your little grid and you're writing right here. For counterclockwise rotations, 90, 180, 270. It works for every quadrant, Saketh. Thanks for asking. It doesn't matter where your original point is. You can use these rules for any quadrant. But remember, they're counterclockwise, and the center has to be the origin. Next week, we'll do plenty of rotations where their center is not the origin, but that's for another week. We're taking it one day at a time here. So please write those down. I was asked if clockwise would make it different. The thing is that rotating 90 degrees counterclockwise, is the same as what? Rotating 270 degrees clockwise. So yes, you could translate these into clockwise. They would be the same rules, they just wouldn't be named the same thing. Let's try it. Take the point -4, 2 and rotate it 270 degrees and tell me the coordinates of the image. I'm going to call, excellent, very good. The answer is 2, 4. Did you get it right? You have to be practicing these. This is our only chance to practice. So 270 says, take Y and don't do anything to it. Take Y and don't touch it. So just you write 2. My mouse always lands in the bad spot. And then it says take X and negate it. So a -4 is a +4. So that's why the answer is 2, 4. Y, comma, -x. We're just using these rules over here. Okay, next one. Try it by yourself and then I'll call on someone. Kendra. Can you do this one for us? -5, 1. Perfect. The rule says take Y and make it negative. Take X and leave it alone. That's what the rule says to do. Next one. Try it on your own first. Y'all are getting these all right. Y'all are awesome. 270 says take y and don't touch it. Take x and negate it. A negative 6 is a positive 6. Last one. Perfect. This is my favorite one, the 180, because you don't have to move anything around. Everybody stays in their spot. You just change the sign of both of the coordinates. So -7, 3. Beautiful. Determine if the following are rotations. If so, write the coordinates of the indicated point from the image. Remember, the first one's called the pre-image, and the second one is, or the result is called the image. So let's look at that heart. Do you think it's a rotation? Yeah? How many degrees do you think? Anyone can type it. Let's see, the coordinates of this point are 1, 2, 3, 4, 5, 6. 1. So -6, 2. So you can use the coordinates to determine if it really was a rotation or not. Because it could look like a rotation, but it could have been translated a little bit on accident. Very good. It is a rotation, and it's a 180-degree rotation. Very good. Notice this is the rule for 180, and it obeyed the rule. All right, let's look at the check mark. There's J. Here's J prime. What are the coordinates? -3, 5. Is that a rotation? Yes. How many degrees rotated? Check the original point and the new point. Is it 90 degrees? Yeah, be careful. We're always going to default to counterclockwise unless someone tells you clockwise. The default, if no one says, is counterclockwise. So this follows the counterclockwise rule of 270. Sure, it's a 90-degree rotation. It is, but it's a 90-degree clockwise rotation, so you have to be careful. Okay, and what about that last one? Not a rotation at all, right? Not a rotation. That's a translation, so we can't give a degree of rotation. No, it's not one at all. Translation 360, you can't do that. Oh, 360-degree rotation. All right, let's do a dual one. Let's do a composition where you're doing two at once. What transformations would map A, B, C to A prime, B prime, C prime? So two things happened here. What two things do you think this is made up of? A translation and then a rotation. Do you think you could switch those? Do you think it could be a rotation and then a translation? Possibly, yeah. So let's look at the coordinates, okay? The coordinates of A are 1, 2, 3, 4, 5, 6, 1, 2, 3. So -6, 3. So how many degrees do you want to rotate that? How many degrees? From there to there. 90. So what's the rule for a 90-degree rotation? -y, x. So this is where A prime would land. 1, 2, 3, 1, 2, 3, 4, 5, 6. And then what would we need to do to get it to the real A prime? Translate it. Right 4. Right? It needs to move this way a little bit. So the answer is, it's a 90 degrees counterclockwise rotation, then a translation 4 units to the right. Can't do it that way. No one's typing. I don't know. You're in there like 3 times, Neil. Because you're signed in. That's why you're getting an echo, Neil. Because you're signed in 4 times. We're going to move on from that one because we need to do a few more rotation things. These are going to be things that are not 90-degree increments, okay? Sorry, I wasn't recording. 2 types of symmetry. There's reflectional symmetry, but there's also rotational symmetry. Reflectional symmetry means I could draw a line, and everything on one side of the figure will be identical, will mirror itself on the other side of that dotted line. Now, rotational symmetry means that there exists a point where if I rotate around that point, that figure is going to fall right back on itself again. It's going to be identical. If I rotate that figure 90 degrees, it won't look any different. If I rotate it 180, it won't look any different. If I go 270, that figure won't look any different. It maps to itself. And that's the definition of rotational symmetry. How many lines of symmetry does a regular hexagon have? How many lines of symmetry? What do you think? 1, 2, 3. Are there any more? I did side to side, side to side. What about vertex to vertex? 4, 5, 6. And that's curious. It has 6 sides and it has 6 lines of symmetry. Coincidence or not coincidence? Okay, what about a regular pentagon? Definitely has that one. If it's regular, does it have any more? So I connected vertice to side. I bet I could do that here. Vertice to side. Vertice to side. Vertice to side. Oh my goodness, how many did I draw? 5. Excuse me. So that's not a coincidence. That is a rule. A regular polygon will have the same number of lines of symmetry as the number of sides. So that was not a coincidence. That happens every time. All right, now let's do rotational symmetry. What's the degree of rotation from vertex to vertex in a regular hexagon? So if I wanted to rotate from here to here, how many degrees would I rotate? So we're always taking 360 and we're dividing it by how many parts that we have. What's the degree of rotation in a regular pentagon? It's the same thing. We're going to take 360. How much do I travel? We're just going to divide it by the number of sides, the number of angles. So 60 and 72. Good? Good. All right, we are almost done. Only 2 more slides. Mixed practice. So it's easy to deal with these things when they're all by themselves, when they're alone. Reflections, translations. But now, if I put them all in one slide, these could be reflections, rotations, or translations. So let's see if you can do these. You can look at your rules today, but you need to be able to do these also without looking at your rules. Okay? XY becoming X negative Y. Because of time, I'm just going to have to write it. Okay? What changed? Everything stayed in its spot, but the Y became negative. So that's a reflection over the X-axis. Reflection. When you reflect over the X, you change the Y. All right, what's this one? This one's totally a translation. And where did we go? Up 4. The next one, now, they traded places. That looks more like a rotation to me, right? So that's a rotation. How many degrees? That's the rule for 90-degree rotation. Next one, when there's numbers involved, you can always bet it's a translation when you see some constants in there. And where did we go? Left 2, down 3. Next one, okay, negative X, negative Y. Remember I said this was my favorite rotation because all you have to do is change everybody's sign. You don't have to move anybody. So this is a rotation once again, and it's 180 degrees counterclockwise. The last one, everything stayed in their spot, but the X became negative. So when you reflect over the Y, you change the X. So it's a reflection over the Y axis. And the more homework problems you do, the better you're going to get at this. Last slide of the day. This one, I have a pre-image and I have an image, and I just want you to write the rule. What happened from the pre-image to the image? So I did the first one for you. The 3 became negative, so negative X, and then Y plus 3. So that would be a reflection over the Y axis, and then we'd be going up 3. Okay, let's try the next one. What happened here? The 2 became 0, so that looks like X minus 2. And the negative 2 became 2, so it looks like negative Y. So that'd be a reflection over the X-axis and then left 2. All right, let's try the next one. Ooh, this one's not a rotation or a reflection because our numbers totally changed. From 11 to 2, what would that be? X minus 9. And from 11 all the way to negative 10, that'd be Y, can't even fit it, minus Our favorite number? 21? And the last one, what happened here? 4 became 4, or sorry, negative 4 became negative 4. So that's just plain old x. And 7 became negative 7. So negative y. So that would be a reflection over the x-axis. So none of those ended up being rotations. All right, we are done with today's lesson. Please, please, please do that rotations homework. New year, new goals. Do homework every night. Bye.